Okay, I'll start. Hi, this is Fabia Thomas, and we are doing a project on early detection of chronic kidney disease prediction. And let me explain the data analysis. So first, you have to install all the necessary modules. Over here, we've already installed all the modules. Next, we have to import these modules. After you import, we've already uploaded the data set, and now we are converting it into a data frame and storing it in a variable called data. And we are printing the first 5 rows using data.head and the last 5 rows using data.tail. Now we don't require the column ID, so we are going to drop the column ID. And then let's just print all the column names to just see the columns. And we can rename the column names to increase the readability. So whatever desired name you can give. Next, we are going to describe our data frame using data.info. So over here, you can check the not null count and the data type of each column. Now our target column is class. And so now we are going to find the unique categories in class column. We can see that there's CKD, CKD/T, and not CKD. And CKD/T and CKD are the same, so we can replace CKD/T with CKD. Now, if we print the unique, only CKD and not CKD will be printed. Next, we are going to separate it as categorical and continuous variables. So we are going to have a variable called cat calls and set all the categorical variables into that. And then we are just printing all the categorical columns and seeing all the categories inside the variable. We can see that RPC count, WBC count, and packed cell volume is not categorical and they are continuous. So we're just removing that from the data frame. And next, we are creating a continuous column and we are setting all the continuous columns into that. And we're just printing all the continuous columns to check the values. Over here, we can again see specific gravity, albumin, and sugar is a categorical variable. So you're removing from continuous underscore calls. And you're adding that in cat underscore calls because they are categorical variables. And you're adding the RBC count, WBC count, and packed cell volume in continuous calls as they are continuous variables. Next, again in coronary artery disease column, you're checking for /T no and no, both mean the same. So you're going to replace /T no with no. And the same goes with diabetes mellitus. And you're just printing. Checking if there's any null values for every column. And here you can see that every column has null values except the target column, which is class. And next with data.isNull.sum, you're just finding the number of null values in each column. Next, you're converting the packed cell volume, RBC count, WBC count to numeric data. Over here, all the continuous columns, you fill the null values with the mean of all the values. So we've done that here. And next, all the categorical columns, you're going to fill it with the mode value. Next, we are going to do the label encoding for each and every column in the each and every categorical columns. We can now again we use data.info to describe the data frame, and over here we can see that there are everything is filled and there are no null values, and you can see the data type as well. Over here, next step is to separate it into independent and dependent columns, and the independent columns are there above, and the dependent is only class variable. And you're just printing the shape of them. Next, you're just describing the X data frame, and you can see the values. Next step is to split the data set into training and testing data, and you're going to print a testing and training shape. Then using the logistic regression model, you're going to train the model. Next, you're predicting for using the testing data, and you're predicting using the custom data. Then we can find the accuracy of the model, and also the confusion matrix is displayed. Next is to generate a pickle file. And if you see on the side, a pickle file will be generated. Now over to Girish Kumar to talk about the web application.
So hi, this is Girish Kumar S. So now I'll be explaining the entire web application codes. So first we are importing all the necessary modules for the web application. The Flask module is to build the Flask is a web framework for building the web application. The request is to send API requests to other third-party services. Here we'll be using it for the IBM Cloud Service. We're also importing the math module, SMTP-lib, SSL, and email modules to send the emails. So now we are initializing the app module. Since we are using the IBM Cloud Service for our deployed machine learning model, we won't be using the saved machine learning file in the previous step. So the first, when the user hits the slash root, the index.html file will be sent to the user. So next, when the form is being submitted from the index.html, the slash prediction route will handle it along with the post request. When the form comes in a post request to the slash prediction route, it will handle it. So now we are storing all the input form values in the respective variables, and we are appending all the input form variables into the input underscore features list. We are also appending the input features list into the features underscore value list, and we are also keeping a separate list for all the input column names. So once these values are framed, the features underscore value and the features underscore name list are framed, we are going to send this to the IBM Cloud Service in which our machine learning model is deployed. So now we have defined the API key for our IBM Cloud Service, which we got from the IAM from the IBM Cloud. So here we are authenticating the API key, and we are getting a auth token in order to access our IBM Cloud Service for our machine learning. So now we are framing the header for the request as well as the payload, which is the body for the request. In the header, we are having the content type, which we will be sending in JSON format. So we are mentioning it as applications or JSON, and the authorization, the machine learning token, the ML token, authorization token, which we got from the token underscore response. The payload underscore scoring will have two values, which will be the fields, which is the features name, the column names, the values, which is the features underscore value. Now we will be sending this payload as well as the header to this URL endpoint, which is the URL for the machine learning model deployed. So as you can see, we are sending the body as well as the headers. So once we've got the response from the IBM Cloud model, we'll be storing it in the prediction variable, and we are checking whether the prediction is 1 or 0. 1 stands for the user doesn't have a probability of having chronic kidney disease. 0 has a probability of having chronic kidney disease. We are also storing the probability values here, and these values are just a copy of the values entered by the user in a correct format. So these values will be used to send the email report to the user. So we are checking if the prediction is 0, then we are rendering the prediction CKD HTML file, and if else we are rendering the prediction no CKD HTML file along with these probability, the input values which we got from the user. So here the respective page will be rendered to the user, and there will be a submit form to send the email of the report. So the send mail route will handle it. We are getting all the parameters which we mentioned in the previous step, and also the to email address and the prediction value. So once this is framed, we are mentioning the email underscore sender, the email underscore receiver, We are framing the subject, we are framing the body of the email, and we are sending it. So this will send, the SMTP will be creating a session and will be sending the email to the user. So now in order for us to start the web app, so we'll be going to the terminal and we'll be entering the, we have created a virtual environment. So we'll be activating the virtual environment and we'll be starting the Python app.py, which will be starting our web application server. So now our application started and the application is available in this particular URL. So now when you go to this particular URL, we can see the index.html. So now Madhav will continue on the working demo.
Hi, this is Madhav. Now we are going to see the demo of our application. We have to enter the given details: blood urea level, blood glucose level, whether we have coronary artery disease or not, we have anemia, whether the pus cell is normal or abnormal, red blood cells, normal or abnormal, whether we have diabetes or not, and pedal edema, yes or no. And we have to click submit. So we are given that your chances of having chronic kidney disease is less with 84% of accuracy. This given set of data shows that this person doesn't have CKD, that is chronic kidney disease. Now we can enter our email ID to get the report and click send mail. We will be received with an report. We have received the report and the given mail ID. Over to Aryan.
Hi, this is Aryan. So now we'll be entering our next set of values. So first, blood urea level is 66 and blood glucose level is 93. And the next is coronary artery disease, yes or no. You have to select no. And the next is anemia, yes or no. You have to select no. And the next is pus cell, normal or abnormal. You have to select normal. And the next is red blood cells, normal or abnormal. You have to select normal. And the next is whether you have diabetes or not. You have to select yes here. And the next is pedal edema. You have to select no here. And finally, you have to click submit. This shows that you may have chronic kidney disease with 87% accuracy. So if you need a report, so you can enter your mail ID below and click send mail, and the report will be sent to your mail. So this is a report. So this is our working module of early detection of chronic kidney disease. Thank you.
Thank you.